Good day, everyone. This is Stefan of Engineering Through Sight. We are here to discuss about the geometric progression under the topic of algebra. Geometric progression, the definition, is a sequence is said to be a geometric progression if its succeeding terms have a common ratio. The corresponding sum of all the terms in geometric progression is called as geometric series. For geometric progression, there are two formulas of it. First is the last term or the nth term formula, which by which a sub n is equal to a sub 1 times r to the power of n minus 1. For the second formula, the sum of all terms formula, where s is equal to a sub 1 times r to the power of n minus 1 all over r minus 1, or s is equal to a sub 1 times 1 minus r to the power of n all over 1 minus r, where a sub 1 is the first term, a sub n is the last term or the nth term, n is equal to the number of terms, and r is the common ratio, or a2 over a1 or a3 over a2, and so on. Example number 1. The fourth term of the geometric progression is 216, and the sixth term is 1994. Find the eighth term. A 17,649, B 17,496, C 16,749, and D 17,964. Solution. The given is a sub 4 is equal to 216, a sub 6 is equal to 1994, a sub 4 is equal to a sub 1 times r to the power of 4 minus 1, where n is equal to 4. So, applying the given above, 216 is equal to a sub 1 r times r to the power of 3. That is our equation 1. For solving for the equation 2, where a sub 6 or the sixth term is equal to the a sub 1 times r to the power of 6 minus 1, where a sub 6 is equal to 1994 is equal to a sub 1 times r to the power of 5. That is our equation 2. To get the to get the value of r, we should divide the equation 1 and equation 2. So a sub 1 times r to the power of 5 all over a sub 1 times r to the power of 3 is equal to 1994 over 216. Simplifying, we should get an r squared is equal to 9, and by solving it, we should get an r is equal to 3. Substituting r is equal to 3, 216 is equal to a sub 1 times r to the power of 3. 216 is equal to a sub 1 times 3 to the power of 3. And we should get an a1 is equal to 8. A sub 8 is equal to a sub 1 times r to the power of 8 minus 1. And it is equal to 8 times 3 to the power of 7, and we should get an answer of 17,496, which is the letter B. Therefore, the eighth term of this geometric progression is 17,496. Example number 2. The sum of the first terms of geometric progression 2, 4, 8, and so on is blank. A 1023, B 2046, C 225, D 1596. Solution, we should take first the given, which is a sub 1 is equal to 2, a sub 2 is equal to 4, and a sub 3 is equal to 8. Also, we should the n is equal to 10. So by inspection, the common ratio is equal to 2. Then we should take the sum of all terms formula, which is equal to S is equal to a sub 1 times r to the power of n minus 1 all over r minus 1. Substituting all the given above, 2 times 2 to the power of 10 minus 1 all over 2 minus 1. And simplifying, we should get an answer of 2,000, okay, 2,046. So the answer would be letter B. Example number 3. In a noontime show, a number of wealthy men agreed that the first one to arrive would pay 10 centavos to enter, and each later arrive would pay twice as much as the preceding man. The total amount collected from all of them was 104,857.50 pesos. How many wealthy men paid? In a noontime show, a number of wealthy men agreed that the first one to arrive would pay 10 centavos to enter, and each later arrive would pay twice as much as the preceding man. The total amount collected from all of them was 104,857.50 pesos. How many wealthy men paid? A 18, B 19, C 20, D 21. Solution, we should gather the given first, which is A sub n, or the first term would be 0.1, since 10 cents it is 10 centavos. The common ratio would be twice, or 2. So the formula we should apply for this sum of all terms formula, which is equal to S is equal to a sub 1 times r to the power of n minus 1 all over r minus 1. Applying all the given above, the sum would is equal to 104,857.50 is equal to 0.1 times 2 to the power of n minus 1 all over 2 minus 1. 2 to the power of n minus 1 is equal to 1,048,575. 2 to the power of n is equal to 1,048,576. Take ln, or natural logarithm of both sides, so to get the n variable. So ln 2n is equal to natural logarithm of 1,048,576. By rule, n times ln2 is equal to ln 1,048,576. Simplifying, we should get an n of 20. The answer would be letter C. This is 20 wealthy men paid. Thank you for watching, and please don't forget to like, share, and subscribe for more videos like this.